Hello everyone, welcome back to my channel. Today let's go over a medium level question that I first solved about a year ago, and I was able to just resolve it on my own without any assistance about 10 minutes ago. So I'm really happy about this, and as you can see, apparently last February I tried it but I couldn't do it, but today I came back to it and I first solved it last October. I first tried it a long time ago. So it's a good time to review. And basically, they're asking you to get the sum of the subarrays of length k, given that they are distinct, meaning that each element can appear at most one time. This is not, this is, because you notice that 9 has a frequency of 2, and then here is 3. That's bigger than 1. So let's get every subarray of length k, and I'll show you my approach. So minus k plus 1, and basically we just want to make a counter of the current subarray of length k, and if every value is at most 1, then we can just take the maximum of answer and the sum of the current subarray, right? And then we just return answer at the end. So let's run this and submit it. So the problem with this is n, and then this is n as well, and this is really slow. So the sliding window approach is get rid of this, or add this, get rid of this, add this, get rid of this. So at each iteration, there are at most only 2 operations, add, remove, to get the window of size k. So what I did is I created the counter first, which is I up to k minus 1. So that gives us this, and then we can just say c of nums of I plus k minus 1 plus equals to 1, and then here c of nums of I minus equal to 1. If c of nums of I equals to 0, then we can just delete it because a 0 frequency number doesn't appear. And let's go ahead and print the counter. Okay, so now you can see we get all the frequencies of size 3, which is great. And now we just have to figure out whether the biggest key is at most 1. So let's create a sorted list based on the dictionary values. Sorry, not keys, the values have to be cannot be bigger than 1. So let's go ahead and add c of nums, or let's discard c of nums of I plus k minus 1 because we're changing the value. So that's getting rid of the old value and adding the new value. If we go from 1 to 2, that's deleting a 1 and adding a 2 in our sorted list, and this is going to keep it in ascending order. So, and then we can just add nums of I plus k minus 1, and then same thing, sl dot discard c of nums of I, and then sl dot add c of nums of I, and then here sl dot discard 0 because we don't care about zeros, right? So now that gives us an easy way to just compare the frequencies. If we print C and SL, you'll notice that these are just the values in sorted order. Or, yeah, they should be. Let's see what's going on. Discard 1, 1, 4. They should be the values. Yep, adding and discarding. Discard c of nums of I. So the biggest value is something about this window doesn't look right. I'm not sure. But if SL of -1 is less than or equal to 1, then we can take the max of the current subarray, the sum of the current subarray, or like this. Wait, this is something is wrong here. So yep, we're looking for the values this time. And yeah, this is not getting rid of the values. This is weird. Let's print C and SL first here. Yep, that's right. And then CNSL 1, 1, and 1, not 1, 1, 4. So the value itself is removed. C.values. Yeah, this am I making a bug here? Adding. Something is a bit weird. So I can see here, why did we add 4 is my question. Right, so we're gonna discard 0 if it's in here. Oh, C of this. Sorry, I made a bug here. Okay, cool. So there we go. So just a small bug, and let's submit it. And this is slow, obviously, so to get the sum of every subarray, let's just do some prefix sums. Cumulate nums, and then if I is less than or equal to 0, then, for example, if we have 1, 2, 3, 4, 5, we're just going to accumulate it 1, 3, 6, 10, 15. The sum of this subarray is this minus this. If this is less than or equal to 0, then it's just the whole thing. That's just 6. So if I is less than or equal to 0, P of I plus I plus K. Otherwise, P of I plus K minus P of I minus 1. Okay, so it might be minus 1. Okay, so we don't need this. Because this is minus 1, that's why we're doing that there. Okay, and there you go. Passes all test cases. So again, I'm super happy that I was able to come up with my own solution to this question without any help and solve it completely on my own after about a year. So that's it for this video, and thank you for watching.